Hello there. Here's the solutions to related rates. I just got done talking to you guys, and I just graded your homework and sent it back to you. Your credit was just based upon doing it. But these are good questions to study for the quiz on Friday with. All right. Area question. Talked about this a bunch of times. Here's another one. I mean, no big deal. It's just solving for dRdt instead of having dAdt with the thing you have to find. Number 3, definitely know how to do. Filling a cone. In fact, let's definitely say that this guy is going to be on the quiz. Okay. Key is when you look at the original quantity equation, you have more variables than you want, so you need a secondary equation. And that comes from similarity, where the shape of the container is similar to the shape of the substance that's going into the container. And you can write a proportion. And then once you get an equation of one variable, a function of v in terms of h, then you can take the derivative and get the rate equation. Okay, so in this case, dr dt was given to you in terms of the variable r, but that is the rate, so you don't have to do anything with this except for when you go to substitute, you have to put in what the radius is at that given moment of time when you're trying to find dv dt. For all of these related rate problems, units is required. When you're done, you have to think about what the quantities are that you're talking about. Like this is volume and time. So volume is a cubic measure. When we did area, this was a square measure. If you were in Miss Birch's class, you would probably put all the units in for each of these rates or quantities, and then you could actually do dimensional analysis. You can see that you get here centimeters squared times another centimeter. So that would be centimeters cubed, and you could kind of reason out what the units are in there. Person walking away. So what's changing is the length, is distance from the wall, as well as a shadow. So this will be in feet per second. And he's walking away, so his shadow is getting bigger, so that's a positive number. And then here is the where's the other half of it? We just had it. There we go. So here is the part that involves the Pythagorean theorem to find the rate of change of the distance from the observer to the rocket in air. And then this guy here goes along with this. This would be a good bonus. This part is, I know you guys are just watching, so you got to go back and look at this and think through it, and try it without looking, kind of stuff. Like this isn't. I mean, it's kind of cool, but it's not that obvious if you haven't really sat down and done it out. So I recommend you do that. Okay. Talk to you soon.